What I want to look at here is what's called atomic mass units. What we'll do is derive what this really is, and it'll just give you a little bit more information on it. So we've got carbon-12, that's the non-radioactive carbon, just your normal garden variety carbon, and we use this to derive our whole average mass unit. We have to have something as a reference, and this is the one we use. And I think you probably know with Avogadro's number that if you've got Avogadro's number of atoms, then you'll get that atomic mass. So Avogadro number of carbon-12s will give you the 12 grams. So Avogadro's number, let's just have a look at my notes, it's been a long time since I did chemistry, is 6.022141179 times 10 to the 23. Now that many atoms will give you 12 grams. Alright, so how much does 1 gram weigh? Well, we'll just divide 12 grams by that and we'll get the weight per carbon. So that, let's just write 12 grams times 10 to the minus 3 divided by Avogadro's number, that will give us the mass per, so exponent minus 3 divided by 6.022141179, the exponent 23 gives me 1.99. Let's get, we always want to do a few decimal points with this. 264654 times 10 to the minus 26. So that's our 12 grams divided. So that's the mass per carbon-12. Then what we do is we don't want the mass per carbon-12, we want the mass per nucleon, and that's what an average mass unit is. So now we have to divide that number by 12, which gives us, let's just do it, 1.6605305 we'll go, times 10 to the minus 27 kilograms. Now that's the mass of an atomic mass unit. So if that's the mass of an atomic mass unit, we've got it in kilograms. You're going to use those often, and I think what we have found, we can then give protons, that sort of thing, an atomic mass unit, neutrons, and the proton, I think you should know already, is a little bit smaller, so it's 1.007 atomic mass units. That's the proton. The neutron is 1.008 atomic mass units. Electron's obviously pretty small, we don't need to write it down. The neutron, as you know, in beta decay breaks down, emits a beta particle, and you end up with a proton, so the atomic number actually goes up. So in these calculations we can use kilograms, we can use atomic mass units. Let's also convert the atomic mass unit into electron volts. So we'll use our E equals mc squared, and we'll find out how much that's worth. So that's the mass times 3 exponent 8 and we end up with 1.49448. 44849. What's that? Times 10 to the minus 10 joules. And I want to convert that into electron volts, so I will divide by the charge on electron. And I get 934, and it goes 0.05, and that is mega electron volts. So once you've got an atomic mass unit, if you do your calculations in atomic mass units, what you'll find is sometimes it's just more convenient to use the electron volts. So that's our atomic mass units. That's our electron volts, or using electron volts as well. So we call this converting to electron volts. And that should do it for that little one.